Section 7.5, we're going to look at solving special types of linear equations. And this will obviously make a little bit more sense here as we just do a couple examples. So, first of all, there are three different scenarios you could be faced with when looking at a linear system. The first is that you have two completely distinct lines. In other words, they are two completely different lines. If that's the case, then there will be exactly one point of intersection, and that is your solution. Okay. A second scenario is that the two lines are actually the same line. Okay, so you get two equations that really, when you simplify them down, they end up being the same line. If that's the case, well then every single point that lies on this line is a solution, because again, it's the intersection of the two lines, and therefore there are infinitely many solutions there. And the last scenario is that you have two distinct lines that happen to be parallel. Okay, clearly we know by definition that parallel lines will never intersect. And so hopefully it makes sense that if lines are parallel, there will be no solutions to the system. So those are the three different scenarios we're looking at. Okay, so we're going to show that this linear system has no solution. We're going to show it using two methods. We're going to show it by graphing, and then we're going to show it by elimination. So if I graph the first equation, okay, the first thing I want to do is rewrite both of these. So I'm going to take these guys down here. When I rewrite them, I'm going to add 2x to both sides. So y equals 2x plus 1, y equals 2x minus 3. You know, at that point, again, you recognize, oh, they have the same slope. Well, then you know they got to be parallel, but let's just graph anyway. So when we graph this thing, -3, and then it's up to right 1, up to right 1. So your first line is here. And the second line is +1, up to right 1, down to left 1. All right, and so you recognize that they have the same slope. They're never going to intersect. Therefore, you'd say no solutions. Now, if you don't want to solve by graphing, which again, as I indicated throughout this chapter, that graphing is probably not going to be the first method of choice for most people. The second method, you're going to look to eliminate. And so I see y and y here, and so I know that in order to get them to eliminate, I must subtract the two equations from each other. And so you get -2x minus -2x. Well, that's -2x plus 2x. Those cancel. Y minus y cancels. So really all you have on the left-hand side is 0 equals 1 minus -3 is 1 plus 3, which is 4. 0 clearly does not equal 4. Therefore, there is no solution. So again, if you end up with a false statement, it's no solution. Very similar to what we've been doing pretty much all year long as far as all real numbers versus no solution. So again, example 2, same idea. I got to rearrange first. So for the first equation, I'm going to subtract x from both sides. So I get 3y equals -x minus 3. And then I got to divide everything by 3. So I get y equals -1/3 x minus 1. Okay, so I can go ahead and graph that now. So -1, and then it's -1/3. So go down 1, right 3. Up 1, left 3. And so this first line looks something like this. And then for the second line, again, I got to subtract 3x. So I have 9y equals -3x minus 9. Divide every term by 9. So y equals -1/3 x minus 1. And you'll see that those two equations are exactly the same. And so what ends up happening is your second line ends up being the same as your first, and clearly those lines intersect at every single point, and so therefore there are infinite solutions. Now this one, it would not make sense to say all real numbers. Okay, you have to say there are infinitely many solutions, because again, remember, the solution of a system is a coordinate. So in other words, this point is 1. Let me get a different color here. This point is a solution, so is this point, so is this point, so is this point. You get the idea. Every single point that lies on these lines has to be a solution. Now if I solve this problem by eliminating, I'm going to multiply the whole first equation by 3 first. And so when I bring that down here, it ends up being 3x plus 9y equals -9. And so now I got to try to eliminate variables. I'm going to eliminate my 3x, so I'm going to subtract them. 3x minus 3x, 0. 9y minus 9y is 0, equals negative 9 plus 9, which is 0. 0 does equal 0. That's a true statement. Therefore, you'd say infinite solution. Infinite solutions. Okay, example 3 says determine whether or not determine whether the system has no solution or infinitely many. And so really it just comes down to solve. Okay, solve the system. So I'm going to take and rearrange this first equation. I'm going to subtract 2x from both sides. So I get negative 2x plus y equals negative 7. Now I'm going to try to solve by elimination. So I'm going to go ahead and multiply the bottom equation by 2. And so now the two equations I have, I'm going to rewrite the first one. So I have 4x minus 2y equals 14. And then the second equation here becomes negative 4x plus 2y equals negative 14. I got to get my variables to cancel. I'm going to cancel my x's. So I'm going to go ahead and add these two equations. 4x plus negative 4x, 0. Negative 2y plus 2y is 0. So you get 0 equals 14 plus negative 14 is 0. True statement, so you'd say infinite solutions. In example 4, same idea. This is nice because it's already kind of written for me, so I'm going to multiply the whole bottom equation by 2. And so the two equations I'm working with are negative 8x plus 2y equals 4. I just rewrote the first equation. The second equation is negative 8x plus 2y equals 8. And so now I got to get my variables to cancel. So I'm going to go ahead and add. I'm sorry. I want to get my x's to cancel, so I'm going to subtract. Negative 8x minus negative 8x cancels. 2y minus 2y cancels. That's 0 equals 4 minus 8 is negative 4. That is not true. Because that's not true, your answer here would be no solution. Okay, those lines have to be parallel. All right, so hopefully that kind of gives you a pretty good idea as to what we're looking for here. Again, just determining whether a system has no solution, infinitely many, or maybe just one. So now there's two different scenarios that you're faced with there, two additional scenarios I should say. So you may not always be able to find exactly one solution, but you should be able to draw a conclusion regardless.